Okay, 2.4 complex numbers. We are going to review them. Complex numbers involve that I, that imaginary number, correct?
Yup.
Okay, imaginary numbers came about because we had to have a way to deal with what? Where do imaginary numbers come from?
Imaginary number.
Negative.
Negative where?
Negative square root.
Negative square roots or fourth roots or sixth roots or eighth roots or 20th roots. What are all those roots?
Wait, can you only
Even.
do even ones?
Even. Okay. What, Natalie?
Can you only do even ones?
Well, I can take the cube root of a negative number.
Oh yeah, because it turns positive. Oh, that's
No,
okay.
it doesn't turn positive. Three negatives make a
Okay,
negative.
don't worry about
Okay. You don't need to write this down. It's just to tell you. We learned about the has no real solutions. When you were in Algebra 1, they told you x squared plus 1 were no real solutions, correct?
Yeah.
Because you would subtract over the 1, if I'm doing it right, correct? And take a square root. And I cannot take an even root of a negative number. Well, this happens. This happens in math. It happened a lot in math involving electricity and currents and all that kind of stuff. Is that a little bit important to us?
Yeah.
Yeah, just a little bit. So they had to find a way to deal with it. It's kind of like a placeholder. Okay? Because usually by the time you're done with all of it, it ends up positive eventually anyway, correct? So to overcome that, they came up with the square root of negative 1 as I.
You are the square root of negative 1.
Yep. Okay, so we need powers of I. So the square root of negative 1 is I. Well, what's I squared?
1.
How is it 1?
Because
negative 1.
And it's not 1.
Minus negative 1. The
Well,
square root of
the
negative
square
1
root of
times the
negative
square
1
root of negative 1 equals
squared
negative 1.
Would be negative 1, not 1. Okay? We don't really need to remember these because we figure them out? Yes. Should you know that I is the square root of negative 1? Should you know that I squared is negative 1? Yes, probably.
Yeah, but
So I cubed is I times I squared, yes? Okay. Well, I squared is negative 1, and I is just I. We don't do anything with it, right? We don't go put it back into the square root of negative 1. So I cubed is negative I. So I to the fourth would be I squared times I squared,
these are looking like J's.
which would be negative 1 times negative 1, which is 1.
Where does a J go?
That's what I was about it.
I was just...
She doesn't like me. It's fine.
Oh, now I just made a J.
She hates you.
Okay, so can I keep going with this?
Yeah.
Yeah? So I to the fifth, how would we break that down? I times I to the fourth. And so it'd be I times 1, which would be just what? I. Is this pattern going to repeat itself? Probably, definitely, for sure. Now, a question that they love to ask you is something like I to the 767th. Okay.
I.
Well, first of all, I to the fourth is the one we absolutely love because why? Because it's just 1. So if I found out what power of I to the fourth this was and then just dealt with the leftover, I'd be doing great, right? So the way you deal with these is just take this number, your exponent, and divide it by 4. So I have I to the something to the fourth. Got me? Can you put your chair down, please? Okay, so, and then we'll have a remainder, correct? And we're going to deal with that. So 4 goes into 7 how many times? 1. 1 left over? Nope, 3 left over. 4 goes into 36 how many times? 9. None left over. 4 goes into 7 how many times? 1 with how many left over?
3.
3. And I actually probably should have written, and I'm going to fix it. I'm going to put I to the 4th to the 191st, right?
Yes.
Okay. Just because we know I to the 4th is what?
1.
1. So 1 to the 191st is just what? 1. So we have 1 times I squared. Why did I break it up into I times I squared?
Because I.
Do we know I squared
Yes.
is what?
Negative
1. So I have 1 times -1 times I, so I just get what? Negative I. And if I already knew I cubed, I'd be doing even better, wouldn't I?
Yes, ma'am.
So can I do this with any single exponent that I give you?
Yes.
Yes. So you guys want to try one? So I to the 796.3.
It's gonna be
What?
It's gonna be I.
Okay. Really, the only thing I'm worried about is the remainder, isn't it?
Do you always divide by 4?
Yes, because I to the 4th is what?
1.
1.
Oh.
And then we'll be left with either a remainder of 1, 2, or 3.
What if you're not?
Then you didn't divide by 4 right. You could possibly divide by 2 if you wanted to, and then you'd have a remainder of just 1.
But no.
But 4 is nice because a 4 is 1. Did you get I to the 4th to the 1,990?
No, I got
Yes, I had
111 and 3/4.
And
3/4.
Well, 3/4 would be your 3, but I don't know how you got your first number.
I don't know either.
Okay, Brad, 4 goes into 7 how many times?
1.
1. Carry 3. 4 goes into 39 how many times?
I think about kindergarten. But either.
Okay.
How?
Okay, is everyone good with that?
Yep.
Okay, so we're always going to divide by what?
I
4. And again, why are we dividing by 4? Because I to the 4th is what?
Always
1. Okay. So, complex numbers. Complex numbers are a combination of imaginary and real. Okay. So we have the standard form of a complex number is a plus bi. Your imaginary part always comes to the back. A is real, so it's called the real part. B is a real number, and I is an imaginary number, obviously. So it's called the imaginary part. You guys remember doing this?
Yes.
So we have a plus bi. So down at the bottom I have -5 plus the square root of -9. It says simplify. Well, what is the square root of -9?
Plus 3 minus 3.
Square root of 9 is 3, but what about that negative?
Minus
3i. So -5 plus 3i. So what if I had the square root of -9 minus 5? Is 3i minus 5 a correct way to write this problem?
No.
No. I will not say write your answer in standard form because the only way you should be writing your answer is in what? Standard form. Got me?
Got you.
Okay. I'm not going to tell you to write it in standard form because there really should be no other way to write that. It's just like a polynomial. How do you write a polynomial when you multiply it all out? You put it in descending order, correct? That was Algebra 1 when they told you every time. And that was in Algebra 2 when I told you every time to write it in standard form. I will not do that any longer. Because should you know it? Yes. Questions on doing this, guys?
Let me write it down.
Okay. Which part are you writing? The example?
Yeah.
This is a big no, right? Okay. Because the next is just a review of this. Okay, real numbers. A real number is just the A, isn't it? Imaginary number. B cannot be 0 in A plus BI. A pure imaginary number is when A is 0. It's just BI. It's called a pure imaginary number. Okay. And for every real number, could I write it in a complex form if I wanted to? Yeah. How many i's are there? 0. It's just like when I have y equals mx plus b and there's no b, what's really there? 0, right? So, just so you know the parts, pure imaginary numbers, they may talk about it. That's the biggest one I probably would write down as a pure imaginary number has no real part. The real part is 0. And there is in your book, it does say write it in standard form, and you get like 6 for an answer. I would take 6. I'm not sure if the book has 6 plus 0i or not.
Has no real part.
What? A pure imaginary number. Yes, has no real part. A is 0. Am I good?
Your text is really big.
Hmm?
Your word text.
Oh. I was trying to shut it off. It's all noisy. Good now?
Yeah.
Okay, equality of complex numbers. You add the real parts and you add the imaginary parts. Oh, wait, no, this isn't addition, sorry. The equality. Just, you can set real parts equal and imaginary parts equal. If they're not like, can you set them equal to each other? No. So real have to equal real, imaginary have to equal imaginary. So our first example is A plus BI equals 13 plus 4I. So what is A?
Negative 13.
A is, where are you getting a negative?
Oh. Never mind.
Okay. A is 13. What is B?
4.
4. That's pretty basic, yes?
I is I.
I is I, yes. Okay, what about the next one? A plus 6 plus 2BI equals 6 minus 5I.
Did you distribute that?
There's nothing to distribute.
A.
This is my real part, yes?
Mhm.
Is that real? What's the real part on the other side?
Yes.
6.
6. So A plus 6 equals what? 6. So I subtract 6 and get
A 0.
A 0. And so 2B equals what? Negative 5. So B equals
Negative 5 halves.
negative 5 halves. So real to real, imaginary to imaginary.
Don't worry about anything.
You guys ready?
Oh, no.
Okay, here is the addition subtraction. Well, the addition subtraction is, okay, so I have A plus or minus BI. That should be a plus right here. I forgot the plus. Okay, A plus or minus BI, C plus or minus DI. Well, guess what I can only add? Like terms. That's it. Combine like terms. So I have A plus or minus C. And why am I doing plus or minus? Because it doesn't matter if it's addition or subtraction? No. So I combine the real parts and I combine the what? Imaginary. I combined like terms, correct? That's it.
Yes.
I have A plus or minus BI, C plus or minus DI, and it's plus those. I can only combine like terms. So A and C are real numbers, so I can combine them. And B and D are imaginary numbers, so I can combine them. Yep. Yes, this should be plus right here. It should not. That. I have to go back and fix that. Good? Okay, additive inverse. It's the same thing when I solve. If I have A plus BI, the additive inverse is distributing a what? Negative. That's all it is. If I have A plus BI plus negative A minus BI, so it'd be A minus A, correct? Plus B minus BI, so I get just what? Well, I get 0i, which is 0. And anything times 0 is 0? So we have additive inverses. So if I need to solve an equation, can I use that to do it? Yes. I treat these exactly like a variable, except is I a variable? What's it stand for? Square root of negative 1. Ready? Nope. Elena, let me know when you're good. Oh, Austin's still right too. Bunch of people are. Sorry.
Yeah. Should be.
Wow, way to call me out.
I said a bunch of people still are. Austin, you good?
No.
Nope. Okay, let me know when you are.
Okay.
Okay, you're good, or okay, as you let me know when you're good. You're good. Okay, so adding and subtracting complex numbers. So combine like terms, yes?
Yes.
So what can I combine?
4 and 1.
4 and 1, so I can get 5.
5
And 7 minus 6.
is 1.
Do the next one real quick. Just like any other quantity, what do you have to do with that negative? Distribute it. It's amazing how those things we're bad at never leave, right?
And we're still bad.
Hopefully you're getting somewhat better. I think you guys are getting a little better at it.
I'm not.
Garrett, what do you get?
I got just negative 3.
Just negative 3. Do you guys agree with him?
Yep.
Yes, because you would have plus 0i, yes? Okay, so if I wanted to make it a complex number, I could write it plus 0i, but negative 3 is acceptable. If we do an IXL ever, remember to read how they want you to write it because they'll be picky. And I don't remember. It probably switches. What?
Homework then?
Um,
Calm down, Callie.
what's going to do with this?
Well, you should be negative. Combine like terms and you multiply 3.
Think you guys can do it? Do both of them.
I think
Go.
Put your mind to it.
I'm pretty sure I can.
Exactly. Always.
Brad,
I will.
Evan.
Well, that's a problem.
How am I supposed to do it? No.
Should be able to work out you don't answer.
Yeah, we ran into an issue here. You don't have to write out that whole thing. You already have it there.
There, better. There's my work.
Yes, that works.
That works, doesn't it?
The better.
No.
I didn't distribute the first one.
Actually, I never complained. I didn't ask. Yes. Yes, sir. Try to take notes and I'll shut up. Dad. No, you turn out. Okay.
Gentlemen.
It's me.
There, Lena. Is that better? Got some more? Could have made them harder.
I haven't done the.
You could have, but you didn't.
What'd you do with the first 3i?
Yeah.
3i minus 3i. Because you have to distribute your negatives, so this becomes a negative. So that's where I get that 0. That's a big negative. It's fat. Guys think you're good?
Yeah.
Yeah, no. I know.
I don't think I'm good at anything.
We should.
Lena, you good?
I think you'd be a lot better if you
You sure?
sample.
I can wait. Austin's still writing.
Are they gonna have is there gonna be a problem with the fraction in it?
Maybe. It's any fraction. Get common denominators.
Hey,
My Algebra 2 class, my 6th grade Algebra 2 class, they got fractions and word problems last night for homework.
cool.
I don't care.
Okay. Many of the properties, such as additive property of multiplication, associative of addition, multiplication, commutative addition, multiplication, and distributive property of multiplication over addition. They are all the same. Okay? Properties on real numbers apply. Got me? The only difference is I a variable.
No.
No. Please don't pop your gum. So what are you going to do?
You're gonna
Distribute.
Do math.
So
Dumb question.
I've got 4 plus 3i times 2 minus 7i. So I'm just going to distribute like any other problem.
Yes, you
So I get
are.
8 minus 28
That's it, so.
plus 6 minus 21 I squared. Do we match there?
Yeah.
Okay, so now I combine like terms, yes? But what is I squared?
Negative 1.
So this is negative 21 times negative 1 just gives me what?
21.
Plus 21. So I get 29 minus 22i?
29.
Because you combine like.
Because I have 21 and 8.
Oh.
Okay, is that any different than if I threw out an x?
No.
There's one thing different. One. What's x squared? X squared, right?
This is very-
What's I squared? Negative 1. That's the only difference. Guys coming back to you? All this coming back to you? Okay, conjugates, aka difference of squares. And I think we're going to stop after this one because I think this one's for tomorrow. Okay, conjugates, difference of squares, remember? Exactly the same except one is positive and one is negative. In the middle. Do you change the sign of the first term? Nope, just one in the second. So a conjugate, and the whole point of a conjugate is to get rid of the middle term, yes? Okay, so we got to remember that. Well, what's a complex conjugate? Is it any different?
No,
Nope,
ma'am.
it just has a what in it? An I. So when I multiply this out, I would get a squared plus abi minus abi
Yeah.
minus b squared I squared.
Yeah.
So this is 0. Sound effects always, correct?
No. Yes.
What is I squared?
Negative 1.
So that makes this negative b a.
It's already negative.
I know, but it makes it a what now?
Is it
Positive. So I have a squared plus b squared. Now, if you guys remember, and I don't know if you do or not, I don't know why my whole screen moved down. We can factor the sum of squares. Up here is the difference of squares, yes?
Yes.
And you know how to factor that. You can factor the sum of squares as well. What's going to be in it when you're done? An I.
I'll always be.
So if I had 9x squared minus 16y squared, are those all squares? Yes? So this would be 3x minus 4y times 3x what?
plus 4y?
So down here, if I had 9x squared plus 16y squared, the only difference is I need to throw a what at the end? An I. Because an I times I is I squared and changes your negative to a positive. So it would be 3x minus 4y I and 3x plus 4y I. Because when I did this last multiplication here, I would get negative 16y squared I squared. And what would the I squared do to the 16? It would turn it positive, and we would get back to the original problem. So remember when we told you there was no solution when it was a square root of a negative number, and we lied to you, it's just imaginary? You never picked up on they said there's no real solution. Okay? Now, then they told you you couldn't factor the sum of squares, but can you factor the sum of squares? Is there a real solution, though? No, it's a complex solution, but can we factor it? Yes. Okay, so that should be for today, all that we have, because I think tomorrow is... I think we need conjugates today. Okay, what's the conjugate of 1 plus I? 1 minus I. And how can I make sure I'm right?
You can do something.
Could I multiply it out? Yeah. So I got 1 minus I plus I minus I squared. Yes? And so this is 0. So I get 1. Oh, this would just be plus 1, wouldn't it? So I get 2. The main thing is when I was done, do I have a real solution? Yes, that is the point of complex conjugates. So you have a real number when you're done. Got me? If there's still an I running around, did I do it right? No. Okay, what's the conjugate of 4 minus 3i?
4 plus
4 plus 3i. Okay, we'll multiply this out and we won't on the bottom ones. Oh, maybe we... Okay, so what do you get? 16, right? Minus 12i plus 12i minus 9i squared. So 16 plus 9 is... And I know I did that kind of fast. Did you get a real number?
You did.
Well, you should have also.
That was too fast.
Twice.
Please stop whispering like that. Okay. What, Callie?
Why is the square root like that?
Because it was before I could actually, I need to recopy it because I couldn't put it in nicely. So the square root of negative 15. So what's in front of that? There's a 0, isn't there? So this is the square root of negative 15. So what's the conjugate of it?
0 minus square root of 15.
Now, do I have to put the zeros?
Mm-hmm.
No, I don't have to put the zeros. So a positive and negative is going to give me a negative. And when you square root, you get what?
Just the number.
The number inside, right? So my answer comes out to be what?
Positive 15.
Positive 15. Now, if you told me the conjugate was just the square root of negative 15, I wouldn't tell you no. There's nothing wrong with that. Because the square root of negative 15 times the square root of negative 15 comes out to be negative 15. That is a real number, correct? It's just negative. But us putting the negative in front of it, it ends up with being a what? Positive.
I can tell you what D is.
Okay? So you can tell me what D is? So I have 1 plus the square root of 8.
I think it is 4, 1, 5, 8, 7, 8, 13.
Oh, you're telling me the answer. What's the conjugate? 1 minus the square root of 8. So the whole point of this is when I'm done to have no square roots, correct? Okay. So 1 times 1, I got 1 minus the square root of 8 plus the square root of 8.
Oh, never mind, it's not 13, it's 9.
And the square root of 8 times the square root of 8 is
8.
8, so negative 8. So my answer is negative 7.
You can stop being wrong.
Is that right?
Yeah.
Okay. But did I get rid of the square root? Yes. So now I can use this when we get into rational numbers. I can use this to move things because we can't have radicals in the denominator. That's why we have to use the radical.
Yeah.
And can we have imaginary numbers in the denominator? No.
No.
So now I'm going to stop for the day. Today you're only going to have to go to stating conjugates. So
Show you.
now you have the rest.